We know that in our observable dimension, called spacetime, there is no absolute movement in space. Every object that moves does so in relation to some other object, taken as a reference. Excluding the absolute movement in space, the relative movement between celestial bodies, then, seems to be linked only to time, which completes the duality of the continuum. It is difficult for us to envision time as a palpable physical dimension, as would be width and length. In any case, with no measurable time and no absolute movement, the Earth and the Sun should not move away from their original positions, even if they move relative to each other. The Earth's orbit would form a spiral that would unfold in space in such a way that the planet, despite showing a cyclical orbit, would never pass through the same position that it would have passed before. Meanwhile, the Sun would remain immobile in relation to the planet, even following the galaxy's spiral movement and the continuous flow of time. Time is intrinsically linked to the curvature of space. A completely flat space could not hold time, and, without time, there would be no movement. According to astronomers, space would act similarly to a rubber band. Curving space would mean stretching the strip and simultaneously contracting time. If the strip later relaxed, the curvature would unravel and time would dilate, following the movement of space contraction. This complementarity between time and space is foreseen in the theory of general relativity. When the strip of space was stretched, the space would curve, and an increase in elastic potential energy is expected. The strip would stretch in one direction, and the force would point in the opposite direction. The consequent increase in potential energy would have its direct registration cancelled by the complementary contraction of time. Thus, if the arrow of time did not reverse at some point, no longer pointing to the future and starting to point to our past, the increase in potential energy would become fictitious forever. Is that the force involved in the stretch would have an antigravity orientation. There could not be, in this case, a recordable inflationary phase for the universe, since antigravity is considered a fictitious force. Without the contest of time, and without the inversion of its arrow, inflation could not be remembered, even if it were there. The placement agrees with physics, which tells us that within spacetime, the elastic potential energy would always be decreasing, never increasing. It would be null at infinity, where the strip of space would be at rest. From there, it would start to contract. There is no evidence or scientific data that could support the existence of an increase in potential energy. Interestingly, the increase in this energy should accompany the inflation of the universe. It is said that the expansionary phase could not be directly described by space, as it would be the result of its negative curvature, capable of imploding time. Therefore, some physicists relate the beginning of time to the gravitational collapse of a very massive body, forming a black hole. They also maintain that the singularity would have been followed by a temporal inversion. Let's see what John Gribbon tells us in his book, At the Beginning, Before and After the Big Bang. The explosion of the universe from the Big Bang is exactly equivalent, from the point of view of the theory of general relativity, to a time inversion, or mirror image, of the gravitational collapse of a body very high mass, forming a black hole. Note that the temporal inversion would be equivalent to the beginning of time. That is, before gravitational collapse, there would be no measurable time. In the relationship of attraction between the Sun and Earth, the relative movement of the planet would have to be negative in retreat, as this movement would also accompany the inversion of the arrow of time. The space would stretch out in a veiled way in one direction, and the force would point in the opposite direction. Gravity would, then, accompany the inversion of the arrow of time, acting in the form of a positive restoring force. The presence of gravity would exclude the existence of any other force that would point in the opposite direction. Therefore, it is fair to think that the contraction of time in the expansionary phase would generate a predisposition in space for the attraction between the masses in spacetime as soon as the arrow of time was inverted. This would place the inflation of the universe as being prior to the Big Bang event. In other words, the formation of the curvature of space by gravitational collapse would escape any attempt at direct registration due to the complementary contraction of time before the Big Bang.